Good morning, everybody. Thank you for coming to this session. We're excited to be here at the Kubernetes Forum to tell you about GitOps, Kubernetes, security, and pipelines with compliance. A little bit about ourselves. I'm an SRE manager at Rakuten, and we have lots of Kubernetes clusters running in all kinds of different environments, QA, development, and production.
And I'm Brandon. I'm from IBM Research, and I work on container security, so things like encryption, signing, integrity, identity, all the good stuff.
Some of what we'll talk about today, we'll briefly touch on why GitOps is important. Then we'll talk about why security is important in the GitOps context. Then we'll talk about the tools, how you can put it all together with CI/CD, and how you can add security with some security tools. Then we'll briefly give you a demo of pipeline an encrypted container image. Then we'll talk about what it may look like in production, having a full pipeline with DevSecOps and compliance. And we'll talk about what it may look like in the future and for some of these things, and then we'll finally give you some takeaways. So why do people want to have something like GitOps? We came up with these 3 reasons, but basically people want to have a tool that allows them to keep a current state and also a desired state. But not only that, but that same tool automatically changes from that current state to that desired state. Then they also want to know who changed something, what changed, and when it got changed. And for that, Git is a great tool. They also want to be able to automate their deployments to different environments and want to be able to have that visibility across a team or organization and have that transparency with everything that's happening. This is what a GitOps infrastructure looks like. So on the left side, you have developers and cluster operators. And developers usually commit code to code repositories. And that actually kicks off a CI process that builds a container image and publishes that to a container registry.
안녕하세요. 저는
And you could also have
이어형이라고
cluster
하고요.
operators managing
오늘
configuration
어쨌든 쿠버네티스 포럼
repositories,
서울에서
container
첫
Kubernetes
번째
manifest
기술
files.
세션을
And then
열게 되어서 굉장히
when
영광스럽게 생각을 합니다. 그래서 오늘 제가 이제 말씀드리려고 하는 주제는 어떻게 보면 이제 쿠버네티스의 가장 핵심이라고 할 수 있겠죠. 이제 사용자 워크로드가 올라가는 탓을 어떻게 그 중에서도 굉장히 디버깅하기 어려운 케이스들이 있고 저희가 만약에 이제 프로덕션 환경에서 그런 상황을 맞닥뜨리게 됐을 때 이제 대처하기가 굉장히 어려운데 그런 것들을 조금이라도 어떻게 하면 해결할 수 있을까를 알아보기 위한 이제 디버깅하기 어려운 환경에서 디버깅하는 방법에 대한 것들에 관해서 세션을 진행하도록 하겠습니다. 저는 페이스북에서 우선 어영부영이라는 닉네임으로 쿠버네티스 포럼에서 지금 활동을 하고 있고요. 이전부터 KT랑 카카오, 라인 같은 회사에서 이제 오픈스택이랑 쿠버네티스를 가지고 프라이빗 퍼블릭 클라우드를 만드는 일을 계속 해왔습니다. 그리고 이제 뭐 3년 전 정도부터는 이제 주로 이제 쿠버네티스를 가지고 이제 계속 클라우드 서비스를 만들고 있는 중이고요. 그래서 오늘 말씀드릴 팟을 먼저 말씀드리기 전에 이야기를 해야 될 게 저희가 그러면 쿠버네티스를 쓰면서 어떤 문제들이 많이 일어나는지를 이제 살펴보면은 우선 저 같은 경우는 크게 이제 3가지 경우로 문제가 많이 발생하더라고요. 저 같은 경우는 이제 클라우드 엔지니어로 일을 하면서 이제 저희가 보통 쿠버네티스 자체도 이제 약간 관리를 하면서 사용자 어플리케이션들도 관리를 해주고 그리고 이제 그 위에 이제 올라가는 노드들도 관리를 해주다 보니까 이런 크게 3가지 종류의 이제 큰 문제들이 발생합니다. 그래서 쿠버네티스 문제들은 이제 쿠버네티스를 업그레이드를 한다든지 CNI, CSI를 설정을 잘못했다든지 아니면 쿠버네티스 API가 뭐 잘못 동작을 한다든지 뭐 그런 케이스들이 있고 노드 같은 경우 노드 자체에 이제 문제가 있는데 뭐 예를 들면 그럴 때 이제 쿠블렛 설정 같은 게 잘못됐다든지
People also care about compliance. So there are all these different compliances from different parts of the world. So you have GDPR, SOC 2, HIPAA. So people care about these things, so that's why you need that security. So now let's talk about the tools to make it all happen. So First, we have these developer tools. These are open source tools, Draft, Scaffold, and Flux. And basically, they allow you to, or allow a developer to create this workflow to commit code and then automatically deploy to a Kubernetes cluster. And then, so you see Draft and Scaffold are kind of similar. They have their own command line, and Flux relies on other mechanisms like Git, kubectl, and Git.
All right, so to some of the security-related stuff, so we have vulnerability scanning. So this is really finding out certain known security issues in your applications. So there are two types. There's code scanning and image scanning. So code scanning really focuses on libraries that are being used, and image scanning looks more at what is the underlying operating system, and also the different packages that the operating system uses. So code scanning tools are usually language specific, for example, GoSec, safety in Python. And image scanning are usually more generic, so you have tools like Claire and Trivy. So another thing you can do is check for best practices. So example of this is HADOLint, which is basically shell check for Docker files. The idea is you have security best practices there as well. And also there's this organization called the Center for Information Security that releases benchmarks on, for example, what should a deployment configuration look like. Here are certain configurations you should have of them. So onto image signing. So Ricardo just mentioned something about what if something's tampered in the registry. And this is what one of the things that image signing gives you, which is to ensure the integrity of the image, so you know that it's not being tampered with from DevOps to the pipeline. The other thing that it provides is provenance of an image. And this goes all the way from knowing where or who created this image to saying something on the lines of, this image has been through a set of compliance checks that I require. Today, this is most commonly done in Docker Content Trust together with Notary or Red Hat image signing. So we just talked about integrity of images. So how about confidentiality of images? So this is what image encryption is here for. The idea is that the image content is confidential. So in the event that, for example, a Docker Hub or your registry is being compromised, the content would still be confidential. So if you have any proprietary code, any secret algorithms, and so on, this is what it's for. And you can play with this today in Containerd as well as Red Hat tools like Scorpio. So another thing that we look at is secret management. So often applications require some secrets or some credentials to access different services. And why it matters in the DevOps pipeline is that this is where we start creating the secrets, defining what secrets applications need. And there's an equally important part of this, which is to define the identity of the application. So this is through something like Spiffy. And the idea here is that you want to make sure that the secrets go to the correct application on the runtime. So examples of frameworks of this is KMIS and Sealed Secrets and many more.
So in-toto is another interesting tool. It basically allows you to verify every single step of your pipelines. So for example, you may have a build step, you may have a publish step, you create Helm chart or deploy to a certain environment. So you want to verify every one of these single steps. It allows you to do that using these links between these steps. It uses basic asymmetric cryptography, meaning private and public key encryption. And it can also be added to all these CI/CD tools, which I'll talk about in a little bit. Another tool is Spiffy Spire. Spiffy is the standard. Spire is the implementation of that. So it basically allows you to do either workload attestation or node attestation. So in the case of workload attestation, it queries the kubelet and gets information about that workload. And it also queries that workload and tries to verify that those match. And if those match, then it issues a service ID and says that workload is valid. Similarly, Node attestation, instead of querying the kubelet, it queries the cloud provider, say AWS or GCP or Azure, and it also queries the node itself and tries to verify that identity. And if it does, then it issues a service ID. Now let's talk about packaging, some of the packaging standards in open source projects. So first is CNAB. It's a standard that allows you to distribute applications. It has its own command line to create that distribution, and you can add extra security with Notary, which is another Cloud Native Foundation project, and you can provide that provenance using in-toto, which is a tool that I talked about before. Build packs is another tool, and this basically allows you to create OCI images directly from source code. It supports multiple languages, Java, Go, and other languages. And it can be used with this other open source tool called KPack from VMware. It's basically build packs natively in Kubernetes. And then if you want to add extra security, you can encrypt the images because it builds OCI images.
All right, so how do we build a pipeline? So the example that we have over here, we've kind of split it down to 4 different categories. And something you notice is, when you go from the left to right, it goes more from dev to ops. So the first phase, which is the build phase. So this is where you take the code that you've written in application language, and this is where you run all the language-specific things, right? Your linters, your checks, data races, and you want to run all of this when you still have access to the code. And what is produced out of this step is really a binary. And then the next thing you want to do is a containerization, where you want to take that binary and you want to construct a container image, which includes the operating system and packages. So in this case, you would do the Docker build, you do image scanning, image encryption, image signing over here. And that gives you a container image. But an application is not just a container image, right? We need to say, OK, how do we deploy the application and so on? Which brings us to application resource definition. So this is where you define how an application is deployed. You also want to define the identity of the application and also what secrets the application needs, and have the identity established at the point. And finally, the last part of it is just bundling all this up. So something like Helm, CNAB, build packs, and deploy it. So one thing that, two observations that we can see from here is, first, ordering actually matters in the DevOps pipeline quite a bit. So certain tools don't work as effectively later on in the pipeline than before. So one example is certain scanning tools and Golang. For example, when you build a Golang binary, more often than not, the library metadata becomes missing after you build the binary. Another example of this is, you want to scan the image before you encrypt it because you wouldn't be able to scan it otherwise. Another thing to notice here is that security is integrated into the pipeline. So all these highlighted in brown or red are actually security related and compliance related. So this is really, it has to be built in the pipeline, right? Security is not something that you can add on after the fact at the end of the pipeline. And here's a couple of NIST mappings. Basically, a lot of the compliance standards use NIST as a baseline. So here's some of the mappings of how the technology can be used to meet the requirements.
So now let's talk about the CI/CD tools that can help you put it all together, create the full pipeline. So first is Tecton, and what is it? Basically, it's pipelines natively in Kubernetes. So it works very similarly to Kubernetes jobs. It follows the same workflow. When you start a Kubernetes job, it goes into a running state, and when it's done, it goes into a completed state. And if there's an error, then it shows as an error state. The CRDs are basically pipelines and tasks. So in pipelines, you can have multiple tasks, and inside those tasks, you can have multiple resources that are specifically designed for pipelines. And examples of that are images and Git repositories, container images. And then If you want to add more security, you can use some of the native Kubernetes mechanisms like pod security policies, network policies, and if you want to pull a repository securely, you can use that SSL support in Git. Jenkins X is another interesting tool. It's a very complex tool based on the original Jenkins, but it has a lot of other components. For example, it has a chart museum to store the help charts. It has a way to discover those charts. It uses some of the other tools that I talked about before, like Graph and Scaffold. Graph to manage the source code, and Scaffold to build and push those container images. It has its own command line to do whenever you want to start the pipelines, and you can define that using its own YAML configuration file. In terms of security, it can use the existing security mechanisms in Jenkins, for example, LDAP integration or integration with IDP providers. So all the different mechanisms that are supported in the Jenkins plugins. And then it has this nice feature to do auto upgrade using GitOps and Tecton. Another similar tool, Spinnaker, I won't talk about it in detail here, but basically it's a complex tool just like Jenkins X. It has a lot of different components, and it allows you to create that workflow of the pipelines end to end.
I think the switch is on. Hello, test. All right. So let's see what the actual pipeline looks like. So we prepared the demo here. Let me just get off this. So what we're going to see today is we have a sample application that we've created, which is really a very basic Flux application, a couple of lines of code, simple Docker file. But what we really want to see is how do we actually create the pipeline. So in this case, what I'm using here is I have a Minikube cluster, and it's running Tecton. So you can see all the Tecton controllers up here. And so the first thing we need to look at is really what are the inputs and outputs of my pipeline. In this example today, we are going to make it really simple, where our input to the pipeline is just a Git repository. So over here I have a pipeline resource, and it points to this URL, which is the Python application in Flux. And I have the output here that I want to create, which is an image. And I want to say that this image or the URL should be this local registry that I've created. And it's Python app encrypted. So I created these resources. Now let's look at what the pipeline that we created today looks like. So I'm going to skip down to the actual steps. So what we're going to do is we're going to run, first, because it's a Python Flux app, we're going to run Python libsafety that checks the libraries in Python. And then we're going to use huddle-in to do Dockerfile best practices checks. And we will use Canonical to build the image. Following that, we move to the containerization. Now we're going to do an image scan using Trivy. And after the scan is complete, we would encrypt the image using Scorpio, and we will push it to the registry. So now what I'm going to do to kick off this pipeline, which in this case, I've just created as a task, so it's easier to look at. We're going to have the build image task run. And I should be able to see the status of this. So using the Tecton command line, I can see the status of this. I can look at, so you will be able to see the steps here if my screen was a bit smaller, but okay. So we can see that now my pipeline is running. And what we can do is we can look at the logs of it. So now I can see my pipeline running. I can see the steps here. As mentioned before, first of all, you download the Git repository. You run Python safety. All is good. No security vulnerabilities found. Docker-lin also outputs nothing. And then we go into the building of the image, which is, for this pipeline, is really a majority of what it is. All right, now we're copying it to a different format so that's processable by Trivy. It does do the image scanning. All seems to be good with the Alpine version. And finally, we get to encryption and pushing the image. Cool. So successfully run the pipeline. Now let's check whether our image is actually there. So I have this container that I can go into. Let me just get the location of the image. So I have this handy pod that I'm running on my cluster, which I should be able to use to download the image. So I can do a Scorpio copy, and I'm copying it to basically from the registry that I created locally to this local file encrypted image. And the first thing we can see is that it's an encrypted image by looking at the manifest. We see this plus encrypted type over here. But we want to be extra sure, right? So let's go into the blobs as well. And what I'm going to do is I'm going to look at one of the data, the big data layers. I'm going to see how random it is, right? So if it's encrypted, it should be very random. And so I'm going to use this tool called ent, which stands for entropy, to tell how much entropy there is in the file. And if I run it on this blob over here, it says that basically, if I wanted to compress this file, I would compress it by 0%. So you can see that it is indeed, to a certain extent, encrypted. So that was the demo we had. The links, all this is in the repositories over here. So it's all Minikube with have instructions on how you can set it up on your own. So if you want, you can download it, play around with it, and add on things to the pipeline.
Okay, so we saw the pipeline demo, and we want to know what it looks like in production. Putting it all together. So this diagram is out of the Jenkins X documentation. So basically, you will have, say, a developer commit some code on the left side, and the developer will create a pull request, a PR, and then you will have different people in your organization or in your team review the code, review the PR, and that PR would actually kick off a process that includes a build, deploy, package step, and then it deploys to a preview environment. So the developer can see what it looks like in that preview environment. So once that process is complete and the PR is approved, then the developer merges the PR, and then a new process, just like the first one, gets created that includes the build, test, package, and deploy. But in this case, it deploys to a staging environment. So in the staging environment, you can have other people in your organization, like QA teams. They can come in and check everything is okay, or maybe run some automated tests, like Selenium type of tests. And then finally, when that's complete, you can have an automated process or a manual process where they can push the button and say deploy to a production environment. And this applies to also canary deployment or the different types of deployments that you want to do. So what does it look like with security? So you have basically the same components as before, but here, say on the first step, when you create that pull request or PR, you can add a tool like in-toto to verify every single one of these steps, like build, package, and deploy. And then at the same time, you can scan your container images. An example here is Trivy, but there are several open source tools to do image scanning. And then when you deploy to all your Kubernetes environments, you can use something like the Open Policy Agent to make sure that these workloads are running as a non-root user, or they're running with the right permissions. You don't want to have these workloads access your whole host, and so that if it gets hacked, then they can do a lot of damage. You can also have a tool like Spiffy or Spire that verifies your workloads in Kubernetes. And then when you create a second step after you merge the PR, you can also do extra verification with in-toto and image scanning. And then when you publish the container images to your registry, you can use a tool like Harbor, which is another Cloud Native Foundation project that uses Notary to verify the metadata. And also in your registry, you can add more security by scanning, doing an extra scan of container images. So yeah, this is what it looks like end-to-end. You have full security in your pipelines. And on top of that, you can add something like image encryption if you care about what's in your container images and say that you're caring about compliance. Okay, what does it look like in terms of the future? So we'll see maybe on these pipelines new configuration languages. So the word is that YAML is pretty good, but then when people have lots of definitions, it becomes really cumbersome. You have this huge set of YAML files, and then you have to deal with the indentation. So some of these new configuration languages are starting to show up in open source. A couple of examples, Q and DAL. These languages actually allow you to add some source code or code in the language to automate some of those repetitive tasks. And another security aspect is that the open policy agent will be replaced by the pod security policy. So that's something that came up at the last KubeCon. And basically, you can add this open source project called Gatekeeper that implements the open source policy or the open policy agent for Kubernetes. So that will help you keep your configurations more uniform across your clusters if you have several clusters, and keep that security, uniform across the board. And then another aspect is Kubernetes upgrades. So maybe we'll see more of this GitOps approach for Kubernetes upgrades. So one of the problems with the new Kubernetes versions is that the APIs get updated in every release, right? And there's a 3-month release cycle. So that could be problematic for some organizations. So the approach here is just to have a blue cluster and with the older version, say like 1.14, and then if you want to upgrade to say 1.15, you create a brand new cluster and you move the workloads gradually, and then you do the switch over, and hopefully with no downtime if you're running stateless type of workloads. So having that GitOps approach might help there. And then we'll see more integrations with all these different tools, the open policy agent, and more cloud native foundation type of tools. So finally, what can you get out of all of this? So think about security initially, in the beginning. A lot of times people create these pipelines and they become this really big set of pipelines. And then by the time you want to go back and try to add security, most people have to just gut it all out and start from the beginning. So always think about adding that security from the beginning to avoid actually going back. And then patch constantly, patch everything in your infrastructure, run C, your GitOps tools, your container image building tools. Keep the process going constantly. If you want to add that extra security in your pipelines, you can encrypt your images. So if you have valuable data in your container images, for building container images, maybe you can use some of these newer runtimes like Kata containers and gvisor. And then when you build container images, make sure you use unprivileged mode. So don't allow access to your /proc directory on your system, so that if something breaks into your system, then they can delete your file system. And then you can take advantage of rootless builds with some of the tools like BuildKit and Builda. And finally, to put it all together, use some of the tools that we talked about, like Spinnaker, Tecton, and Jenkins X. So yeah, here's some resources, and I think that's all we have. So wait. I don't